Now, ready for this? Okay, we are currently doing the concurrencies concurrencies of a triangle. A line which joins a vertex of a triangle to the midpoint of the opposite side is called a median. Triangle in the given triangle, AM is the median. So, for those of you that, if I give any given triangle, okay, so let's say a scale-in triangle where none of the sides are the same, scale in, I basically join one vertex to the middle. Now, the middle by length, so roughly there, is it? There, right? So what's that called then? Learned the word a second ago. It's called a median line. Is that right? So this length is the same as that length. Well, cool. Right, that's what we've learned so far. Now, centroids. To get the centroid of a triangle, you link up the medians from every corner to that triangle. So we'll do our best here, right? So let's see if we can do it. We'll do it by eye, not necessarily by not necessarily by measurements. So what do you reckon? Say when you think I'm halfway through this length. Right there, is it? Yeah. Now I could take out a ruler and do it, but I don't really want to have time for that. All right. Next one. I'm gonna go along this line here. Whoa. I'm gonna go along this line here. Tell me when I'm roughly halfway. Yeah. Now what should happen is all three sides hit at what's called the centroids. The centroid is actually the center of balance. So if you were to cut out a triangle, if you were to cut out a triangle made of paper, and you were basically it's the center of balance, you could balance it on a stick. All right, you could balance on a stick, and it would work perfectly. So you can cut out a piece of cardboard. If you cut out a cardboard triangle, you calculate the centroid using a pen and ruler. You can balance that. All right, so it's the center of gravity or the center of weight. So it actually has a legitimate use. Now, now, the medians of a triangle divide each other in the ratio 2:1. So let's test that. They think it's 2:1. So let's try my one to see if that is the case. So I'm just going to get my ruler out actually. Now, I'm going to draw along one of the medians. There's the median there. Okay. It's actually roughly 15, okay? So that's 5 and the other one is 10. It's always in the ratio of 2:1. Once again, if I flip that around and I go after the other median, it's going to be, in this case, it's also another issue. If you do really thick points, you can sometimes introduce errors. So there is an error on this one. I'm not quite in the corner, am I? See that there? I'm not in the corner where it should be. Okay. So there it is there. Roughly 3:5. Everybody get? No, not 3:5. 3.2 and 4.8 actually. So that's the length from here to here is 3.2 and that's 1.6. So it's roughly 2:1. Thanks. Now, nextly, the centroid can be given to you by using this formula here. Everybody see the formula on the board? X1 plus X2 plus X3 over 3, Y1 plus Y2 plus Y2 over 3. Very easy, right? Centroid is so easy. Now, circumcenter. This is fun. The circumcenter of a triangle is the point of intersection of the mediators. Mediators are perpendicular bisectors of the triangle. The line segment from a vertex of a triangle to the circumcenter is the radius of the circumcircle. I'm actually going to draw it for you, doing constructions, because you have to do construction eventually. Now, you don't have to do this until 6th year, but I'm going to show you anyway. Here's how you get a circumcircle. Pick a triangle, any triangle. I'll go for Go for another scalene one. Okay. There's a standard scalene triangle. Ever cool with that? Now, what you do is you get a compass out, and what you do with the compass is you go over halfway. You start on one point of the triangle, and you go over halfway. What you do is you draw. Some of you can probably remember something like this: dividing a line in half from junior cert. There's one there. Then you go one on the top like so. Then you turn around. You go to the other side, and then I hate when I do that. Now, guess what my mistake is? Always has to be above half the distance. So, have to go again. I've never done this 100 bloody times before. Now, alright, let's try this again. Different color pen. Right, there's once. Where is my rotator? Oh, there. There's twice. You did TG, did you? In your sleep, yeah? Oh, what did I do that? Has to stay the same length. Okay, and then all the way down. Now, guys, there's one. Have I killed that? Now, the next one would be I pick any other side I want. So I will pick the. I'm going to try and pick the top. So yeah. I'll pick this side here because it might actually fit into the question. Have an idea. I'm sort of running out of paper on top, so I need to just grab all this and drag it downwards. There. Now we can do it easy. Alright, I'm going to do the top one. And once again, don't want to make the same mistake I made last time. Got to go over halfway. Pretty much doing the splits here, okay? Now, we'll do a different color again for this one. There's red, and then go underneath. Once you rotate, there you go. And there's another red one. Go back around the other side. Go up here. Now, just about got away with that one. See where it hits. And then go down, and then go down here. Let's see if we get away with this one. I always miss one of them. The worst thing is, I always miss one of them. One of them is always short. Alright. Now, do you see where the two lines, see where the two red X's are and the two blue X's are? So what you do is you get a straight line, like so, and you come in like this, and then you get another one, and you do it like this. Now, oddly enough, this is going to turn out really weird, but I'll show you now. Right, see where the two black lines intersect each other. Now get this. Hey, looking at his watch. I'm zooming so fast, isn't it, Daddy? Boom. That's it there. A circumcircle, lads, a circumcircle is a circle that goes through all 3 points of a triangle. Doesn't matter if that's an obtuse case. You get what I'm saying? If that was an acute case, it'd look more like what you have in your book. Now, I know a good website for this. What you guys are looking at the board is looking for an ad for an app. Apple are going to pay me 133 million. Oh, never mind. They're going to pay me that. They're going to pay somebody else that. Now, what you guys are going to notice here is, see the circumcenter. The circumcenter is the center of the circle, which is here. Everybody cool with that? You see when the triangle is obtuse, the circumcircle is on the outside, not the inside of the triangle. Now look what happens here. Okay, here's what I want you to picture. I want you to picture town A, town B, and town C. This hospital here, H, this hospital is equidistant to each one of those towns, isn't it? How do I know that? It's a radius each way, isn't it? Now look what happens when I go to Mat Open Ref here and I start messing around with the angles here. So look at this, try and get to C. So if I start making this, if I make this right angles, guess what happens? It's on the diameter A to C. If I make this obtuse, what happens to the circumcircle? center. It's outside the three triangles. If I make it a equilateral triangle, it actually hits the centroid. Everybody cool with that? Alright. No idea what's going on here, but we're going to get off that. Now, stupid ads ruining my fun. Alright, so that's what the circumcircle is. Everybody cool with that? Now, from, excuse me, Jacks, from a formula perspective, here's what you need to do. I want to keep that. From a formula perspective, here's what you need to do. Okay? The first thing you do, if I give you point A and point B, see point A and point B? If I give you point A and point B, I require you to get the midpoint M. I then require you to calculate once you get the point M, I need you to get the equation of the line, the green line here. Ever see that green line? That green line is perpendicular to AB, but it goes through M. Then I want you then to get the CBC. I want you to get the midpoint of BC, which we'll call M2 for argument's sake. Everybody cool with that? You then get the equation of what line? You get the equation. You get the midpoints. Then you get the equation of a slope that's perpendicular to BC but goes through M. You get the equation of a line. That's now your red line. And the circumcenter is where the red line hits the green line. Anybody can sum that up for me one more time? Let's do it on a blank triangle. Right, blank triangle. Scale in again. Alright, go on, somebody do this. 3 points, X, Y, Z. What's your technique for finding the circumcenter? Go on. Step 1, pick a side. Any side. What one do you want to pick? X1. Get the midpoint M1. What you do then? Slope of XY. And then you draw a line. You get the equation of a line perpendicular to XY that goes directly through M. Okay? You need to get that line there. Cool with that? Pick another side. Brian. Brian chose ZY. ZY. Alright. Now, Brian chose ZY. And Brian chose ZY. When does he stop? What does he need first? He needs the midpoint. M2, doesn't he? What does he need then? The slope of ZY. Then you get the perpendicular, you get the line that's perpendicular to M2, don't you? And then you see where both points hit. How do you solve where both points hit each other? Simultaneous equation. And then you end up with your circumcenter. Now I did all this by eye. This should not work. I didn't even take a single measurement. I'm off, but not that bad for us doing it by eyesight, right? Now, that's another one of your questions. So here's what I want you to do. I want you now to find a circumcenter using the technique I just laid down for you. Off you go. Tyler?